Welcome to the Journey Shake Chem. Please do the 2 warm-up questions to the best of your ability, and we'll talk about them in a moment. Now, everything that we start with in the beginning of these equations is aqueous, and they are always double displacement reactions. And the inners and the outers trade places. And therefore, I get 2 sodium chlorides and barium sulfate. In this case, I need to look at my table of solubilities, and you will be given the table of solubilities on your assessment. So you don't have to memorize those tables. That I know that we expect a lot, but I will give you the table of solubilities. Now I look at the negative position, and the chlorides are soluble with sodium and alkali metal, and therefore this would be aqueous. Then I look at the sulfates. Sulfates are soluble except for barium, and therefore this is my solid. And I could underline it, I could put a little S, or an arrow down, or a little CR. All of those would represent solids. Now, everything that is aqueous is separated into its ions because they're floating around in solution. And therefore we have barium ions, aqueous, and 2 chloride ions, aqueous. It's important that we do not put this 2 down below, because that would be saying that those 2 chlorines are hooked to each other, and they're not. They're floating around as ions. And whenever I put salt into water at home, I never saw green gas come out of it. There would be a toxic green gas coming out if chlorine gas was formed, and that doesn't happen. So that's how maybe you could try to remember it. We also have 2 sodium ions, aqueous, and sulfate ions, aqueous. And remember, your ions must have their charges, or we don't recognize them as being ions. We have 2 sodium ions as products, and 2 chloride ions as products, and barium sulfate. And I cannot separate a solid. Now, I want to show you this. I am going to take my safety goggles to make sure that we have to be safe, and I have a test tube here. Now, notice that I have 2 clear liquids, and I am going to take the sodium sulfate and put some in this test tube. Now, this is qualitative, so it doesn't matter how much. I'm just going to use approximately the same amounts of each one, and then I'm going to add my barium chloride. Now, my barium chloride, we must be careful. Barium chloride is somewhat toxic here, and so I will put it and drop it in, and you can see the white crystals that form. See the solid? It's a white solid that forms. Very interesting. Now, if I let this settle, I will see the white solid in the bottom, and the liquid is actually clear. And therefore, I know that the solid, the white solid, is my barium sulfate. That is what the solid comes out to be. And floating around in the liquid are my sodium and chloride ions. My sodium and chloride ions are my spectator ions. And they are not doing anything in this reaction, therefore I can remove them from the reaction. My spectator ions are sodium ions and chloride ions. When I remove the spectator ions from the equation, I'm left with my net ionic equation. Barium ions, aqueous, plus sulfate ions, aqueous, and I get barium, sulfate, solid. I like to underline them. And that would be my net ionic equation. Now, the lab that we're going to do next week, which I'm so excited about, you will have 5 different reactions to do, and they're different colors, and they're just fun. So that's the type of thing you'll do. That's the answer to number 1, and in a moment, we'll do number 2. Now in number 2, again, we have a compound plus a compound, which is a double displacement. In all of these types of equations, they are always double displacement. And what we begin with is always aqueous. And my products are silver chloride and potassium acetate. And then I look at my negative position and I see that chlorides are mostly soluble. However, silver is an exception. Therefore, this is my solid. And acetates are mostly soluble, and especially these two, both of those two are dateless dudes. They never form a solid, and therefore this would be my aqueous. Things that are aqueous, I will separate into their ions. I have silver ions, aqueous, plus acetate ions, aqueous, and potassium ions, aqueous, and chloride ions, aqueous, and I get silver chloride, and I cannot separate that because it's a solid and it's stuck together. Those particles are making the solid. But I have potassium ions, aqueous, and I have acetate ions, aqueous. And things that are identical on both sides of the equation are my spectator ions. Therefore, my acetate and my potassium are my spectator ions. And I can cancel them out of the equation. Therefore, my spectator ions are acetate and and potassium ions. Those are the ones I'm canceling out. And what I'm left with is the net ionic equation. And the net ionic equation is what's left. And I have silver ions, aqueous, plus chloride ions, aqueous, and I get silver chloride as a solid. And that's my net ionic equation. And that's how you do those types of problems. And we will have more practice. So I can't wait to see you tomorrow. I think that we've discussed anything that you need to know. You will have a table of solubilities on the assessment that will be coming up. And we're going to do a lab with net ionic equations. And I can't wait to see you tomorrow. Bye.